to the B.B.N! Better than Bill Nye!
Today's subject, Newton's 3 laws.
Hello, nation. My name is Sir Ben. As you can see, I'm sitting here today on this park bench, one of the nation's most greatest examples of the laws of motion and momentum. Today, I will be greeted by the nation's top scientist, Sir Guy that always rides at 10 speed. Alright, Guy that always rides at 10 speed, what can you tell us about the first law of motion?
Well, funny looking ventriloquist guy, an object at rest remains at rest, and an object in motion remains in motion at a constant speed in a straight line unless acted upon by an unbalanced force.
Thank you!
And it's a great way to stay in shape. Hi, I'm a guy that always rides at 10 speed, and as you know from Newton's first law, an object at rest stays at rest until acted on by an unbalanced force, like that there piece of pizza. Along comes the outside force. Ugh. Now the object will stay in motion until acted on by a second outside force. Along comes the second outside force and... And it's a great way to stay in shape.
An object at rest stays at rest unless acted upon by an outside force.
And it's a great way to stay in shape. Did you know?
Sir Isaac Newton's laws also have to do with inertia, which is the tendency for all objects to resist the change in motion.
This goal shows a resistance to change in motion.
And it's a great way to stay in shape.
Well, hello again, Mr. Guy that always rides at 10 speed. Can you tell us a little about the second law of motion and stop elbowing me? What can you tell us about the second law of motion?
Newton's second law of motion is that the acceleration of an object depends on the mass of the object and the force applied. The equation being A equals force over mass, or force equals mass times acceleration.
Why, thank you, Guy that always rides at 10 speed. Now, is that a good way to stay in shape?
That is a great way to stay in shape.
And how do you stay in shape?
I ride at 10 speed.
That is awesome.
I know.
We'll be back in a few moments.
And it's a great way to stay in shape. The equation for Newton's second law is acceleration equals force divided by mass. In this example, Robbie is going to exert a force of 40 newtons. Tim's mass is 4 grams. So, when Robbie punches Tim, Tim's acceleration will be 10 newtons. In this same example, Robbie is going to be exerting the same 40 newtons of force. Vince, he weighs 8 grams. So when Robbie hits him, he's going to accelerate at a speed of 5 newtons. Oh! In our next example, Robbie got a sword, so now his force is 80 newtons. Tim's mass remains the same. Therefore, Tim's acceleration is greater. In our last example, Robbie is going to be exerting the same force of 80 newtons, but Vince's mass is still 8 newtons, so his acceleration will be less than Tim's. Oh! God! Now, Robbie's been using steroids, so his force is going to be 100 newtons. But Vince's mass stayed the same, still at 8 grams, so he's going to fly even farther. Oh, God! Oh, no! And it's a great way to stay in shape. Consider the following.
Sir Isaac Newton's second law says that objects with larger masses should go not as far as objects with less mass, then this binder should go not as far as this sword.
And it's a great way to stay in shape.
Well, we're back with Guy That Always Rides at 10 speed. And he's getting awfully friendly. So, Guy That Always Rides at 10 speed, now finally to the third law of motion. What can you tell us about the third law of motion?
Newton's third law of motion is that whenever one object exerts a force on a second, the second object exerts an equal and opposite force on the first object.
Why, thank you. This has been a wonderful day of science.
Thank you!
Now,
Newton's third law is that when an object exerts a force on another object, the second object exerts an equal and opposite force on the first, like these cars. Notice how when the first car hit the second car, the first car bounced back a little because the second car exerted an equal force on it, and then it stopped. As we know from Newton's third law, if one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. That's why Robbie comes down on the trampoline pushes him back up with equal and opposite force. Woo! And it's a great way to stay in shape.
I'm a sick one,